I'm Steve Martinelli. I'm a software developer for IBM, and today I'm here to talk about the building identity and access management in OpenStack. On that note, how many people know what OpenStack is? Can I get a show of hands? Okay, about like half. That's good. Quick agenda for the day. It's kind of going to be like story time. Going to talk about what is OpenStack Keystone for those of you who don't know. Going to talk about the different identity sources, authentication methods. It actually should be access management and then federation, and then any future plans that we have. So the quick overview. For those of you who don't know, OpenStack is infrastructure as a service. It's a big project. We just had our summit, our biannual summit, 2 weeks ago in Vancouver. 6,000 people there, huge crowd. It's essentially free and open source. It's all Apache 2 licensed. The main project we're going to be talking about is the Keystone project, and that is the one that provides all the identity and access management to the other components of OpenStack. The other components being your compute, image, object store, block storage, network. A lot of big companies are backing OpenStack, using OpenStack, and I just wanted to give a shout out to these companies because they're probably the top contributors to the Keystone component. So CERN, Red Hat, HP, IBM, Rackspace, and the Universidad Federal de Campina Grande. I got that one right. All right, Keystone. Like I said, it's the identity and access management portion of OpenStack. You're going to access it if you need to authenticate and you want to use the other services. If you want to get the service catalog that has, all the endpoints for the other services, you need to talk to Keystone. And once you've authenticated, you actually get a token, and the token actually stores all this data. Keystone itself is designed to be very modular, very pluggable, so folks can put in their own plugins and extend it the way they want. There's many different ways to deploy Keystone. You can have a very small, or deploy OpenStack actually. You can have a very small deployment, which a lot of developers use, and there's a small project called DevStack, which actually pulls down all this, pulls on all the necessary information that you need and actually starts it up for you on like your little desktop or laptop. And this is convenient for like developing and testing and stuff like that. And then we can have all the way up to like a large scale deployment where you have multiple data centers, multiple regions, multiple like geographically dispersed regions, and then everything in the middle. Now the identity sources, what are the identity sources that we actually support? So one of the ones that I don't like is the SQL-based one. So as part of Keystone, we deploy a bunch of databases. We have a database for showing projects, for storing your projects, your roles, all this other information. And alternatively, you can also use it to store users, but that kind of makes us into a small identity provider, and we don't like that. So you really want to only use this if you're testing or developing on OpenStack. We don't encourage folks to use it. Oh, and some of the text got cut out. I don't know what saving OpenStack means. But it doesn't provide any password rotation, password recovery, any of those things. It's just, you store your username and password hash in a database. Users can come in and look that up. And this is something we want to get away from. We don't want to be in the identity provider game. The second way, and that was one of the very first ways to use OpenStack. And this is kind of like why it's story time, because afterward, now we have LDAP. And a lot of big companies started to get involved. They're like, oh, we have enterprise customers and they all have LDAPs, so we need to enable those users who are coming in from an LDAP point of view. So how can we make sure that they are using it? So we have configuration options so that Keystone can talk to your LDAP just like any other application, just like your email or system login or anything like that. This is pretty ideal, but it's not perfect yet. But this is basically where you want to be if you have an enterprise and you already have an LDAP in there. One of the downsides to it, though, is the other OpenStack services, like the compute service or the image service, they need accounts as well. So they need And you don't want to have to create those accounts in your internal LDAP. I'm sure the folks in charge of your LDAP won't like that. So we ended up doing something called multiple backends. And this kind of bridged the first two together. So you have, your identity can be split up into SQL and multiple LDAPs. The SQL itself being where you would hold your service accounts for your service projects, and then any number of LDAP-related accounts as well. They can all be in there. And this was kind of like the preferred approach for most enterprise customers. They were very happy with this. And then as time went on, we started to get into the federation game, and we started to look at the identity providers and how can we leverage those. And we're going to get into this a lot when we're talking about federation in a few slides, but essentially we want to use this. We don't want to be in the identity provider game. The benefits for this are many. I mean, a lot of enterprises are going to have an identity provider already on hand, and probably the main thing that we like about this is that we're no longer going to be seeing your password ever. In SQL, we were storing it. In LDAP, we were still seeing it in the request. We were just forwarding it to the actual LDAP, so we're kind of acting like a proxy. But now if we start supporting identity providers, well, then we no longer have to see your password, everyone's happier, security's happier, auditing's happier, and it's less work for us. So how can users actually authenticate? Again, this is what I was talking about just a few seconds ago. You're passing your password to the identity service, and in return, you're getting back a token. Then you go ahead and use that token with the other services whenever you make an API call. And also, in case the tokens, they do expire, so you can always actually include a token in your in an authentication request to just refresh it, get a new token. And we also support, there we go, we also support Kerberos too. So so we figured out how the users are actually stored, how can they authenticate. Now how do we actually manage access management? So let's say a user wants to go ahead and say start a VM. So what are the actual steps that he has to do? So first he actually logs into Keystone with their username and password and the project that's associated where the VM is actually living or residing. They get back that token. Now, the trick to all this is the user or the group that the user's in has to actually have a role, because the way this is all validated, it's all role-based access. So the user has to actually have a role in that project to actually be able to turn on the virtual machine. At which point, once he actually gets a token back, he can actually just make a standard HTTP request call to that API over there, /v2 tenant ID, with the token that he then got back. And then it should be turned on, or the request should be rejected. So the token, I keep talking about that. So what does it actually look like? You can see over here, it's actually got the roles. It's actually got the roles that the user has on the project. The project is essentially the scope, the resource that he wants to access. The user block actually just contains a whole bunch of information about the user. This includes their name, what domain they're a part of, their ID. And then the service catalog actually has all the different endpoints for the different OpenStack services. It would be far too long to include here, but it would be actual URLs for the storage, compute, endpoints, things like that. So how do we actually figure out if a user can actually access start a VM? So each OpenStack service actually has a policy JSON file. And it's kind of divided up into logical pieces. At the top, we actually have definitions. And these are, why does it keep doing that? There we go. It actually has definitions which are just kind of used throughout the file for targets and rules. The targets are actually, each target maps to an API endpoint. So for instance, you can see the fifth from the top is actually compute start. That actually maps back to the URL that the user attempts to hit with the token. And then on the right side, we have the rules. We have the rules of compute start, and that says the rule has to be, the user must be either an admin or the owner of the resource that he's trying to use. And that's kind of how policy and resource management is handled in OpenStack. Identity federation, like I said, we're beginning to really dive deep into federation in OpenStack. And we've been probably working at this for about a year now, a year and a half. David Waite was actually back there in one of the summits, who's hiding in the room back there. He was actually part of the first interactions with it. And so we decided to start forcing folks to deploy Keystone in Apache. Previously, Keystone was deployed as an eventlet process, but running it under Apache just simplified things. It made security simpler. It made using plugins simpler. We could leverage ModShib, ModMelon, and ModAuth OpenIDC, which one of the ping folks, Hans Zambelt, actually writes. So we were able to leverage all these identity sources. So if you can configure your Keystone to act just like any other service provider, you can then leverage other existing identity providers in a similar fashion. So essentially what we're hoping, or what we had hoped, was that a user authenticates with the identity provider, and then what we'll see on Keystone is just who he is and information about him. So we're going to see information, basically the SAML assertion or the OpenID Connect claim, we're going to see that as basically environment variables. And I'll get into this now. This kind of relates back to what the first speaker was talking about, creating those mapping rules to actually figure out, okay, so we've got this information about the user, but what can he actually do once he's actually authenticated? Well, this is where those mapping rules come in. And as the first speaker actually pointed out, these can be quite complex. But the gist of it is you want this, on the left-hand side, those are the environment variables that the user is going to have once he's authenticated. That's all we're going to see. You're going to have some username. He's going to be part of some groups. So what does that mean on the Keystone side? What can he actually do? Well, on Keystone, we're still going to want to save groups in an SQL database, which is fine. Those are just a way for us to actually create role assignments. We can, put an entire role assignment of, okay, you guys can start up VMs on this to this group over here, and as long as the mapping engine actually comes out saying, okay, you're part of this group, well, then our job is kind of done. And the mapping rules themselves are on the far right-hand side, where we kind of translate it from a remote entity, from a remote resource, and that's coming from the OpenID Connect claim or the SAML assertion, into a local concept. So the local version of that group would be developers or something. And all of a sudden or admins, and you assign the role of admins to that group, and then they'll be able to use it just like any other user, just how they used to authenticate with Keystone. The trouble with this, as someone had pointed out earlier, was that sometimes this could lead to inadvertent escalation of privileges. I mean, say I didn't intend for that, but I wrote the rule like this, and that's something that we're trying to figure out and something that we know, and it's something that we're also trying to make the user experience a bit better on. We're trying to allow for like blacklist or whitelist groups. Anyway, the way it all kind of works out is the user is going to go to the Apache to Keystone to try and authenticate, but the resource that he's going to hit is going to be a protected resource, so ModShib is going to take over at that point. They're going to go to the SAML IDP to authenticate, get a whole bunch of assertions back. We'll see them as environment variables. Mapping engine kicks in, gets a token, and all of a sudden, that's all we really care about. Once the user has a token, we're all good. Second piece was the actual single sign-on piece, and this was actually collaboration between us, the Keystone team, and Horizon, the web interface, the admin console kind of folks. And this was something that folks really wanted. CERN had proposed this way back when, and but as of the last release, the Kilo release, which is out a few months ago, we actually got this in. And the way it's going to look is that users can actually select whether they want to use their old school username and password like this, or they can actually go through the OpenID Connect flow. And you can configure a default identity provider per protocol. We didn't want to list all the identity providers there. Security reasons, we just didn't want to. But once a user actually hits next, he'll actually go to the identity provider that's associated with Keystone. So in this case here, I've done a quick mock-up with using Google as our identity provider. I log in, and all of a sudden, I'm in here, and I can start fiddling around with my VMs and all this other stuff. And you can see that the user ID itself is actually some ID at accounts.google.com. And the way this thing kind of works, it's very similar, except it starts off with the user actually going to Horizon first, the web interface. And then once they actually select the connect portion of the login, it'll actually do the exact same flow. It'll hit modshib, or in my case, it was modauth OpenIDC. Go to my identity provider, I'll authenticate, get back some OpenID claim or some assertions, see them as environment variables, mapping engine kicks in, gets a token, send the token back to Horizon, and re-authenticate with that token. One of the biggest things that we actually are looking forward to in Keystone and OpenStack in general is the advent of the Keystone to Keystone Federation. And this is essentially kind of like the underpinnings to providing hybrid support. So we're trying to federate identities between two clouds. The way this actually works is that, so you have two distinct Keystones from separate organizations. They could be off-prem, on-prem, doesn't matter. But you want to make sure that they can trust each other. So what we ended up doing was actually providing support for Keystone to act as a very, very small identity provider. You authenticate with it, and then it'll pump out a SAML assertion about your user, very small one. And from there, I mean, Keystone was already acting as a service provider, so we just kind of did the reverse flow of that. And so it's kind of an IDP-initiated flow, which can be seen here. So the user's actually going to go to his local cloud first, and he's always going to have to go there first to get a token. Once he is there, he can submit his token and ask, can you SAMLize this token? Can you make it into a SAML assertion? And then he'll present the SAML assertion to the other cloud. Provided that they're set up correctly, he should then get a token that can be used on the other cloud. And any future plans that we have actually are going to be, so we want to have multi-factor auth. That's one of the things that we're working toward. The guys at Rackspace, they're all really smart, and they really want this because a lot of the users are logging in directly into their portal, and this is something that they need for security on that end. So we want multi-factor auth. They proposed the specification. It looks good, just has to go through the motions. Federated identity enhancements. As the first speaker said, using those mapping rules, those mapping engine, it can be a little bit tedious. You end up copying and pasting a lot of things, and we're looking for ways to improve this. Just making the mapping rules easier by using whitelists or blacklists, and just better client experiences when trying to do the Keystone to Keystone authentication. And then we want to get rid of passwords completely, like between the service accounts. There's no reason for them to be using this. We can just use X509 certificates. And probably one of the biggest talked about issues at the last OpenStack Summit was dynamic policy. Presently, the way we manage the policy files is it's literally a file. It's called policy.json. And you start up a service, and that's what it's going to read from. And if you want to edit that file, you have to restart that service, which is less than ideal. So we want all this stored actually in a database and just be dynamic. There's no reason for us to actually have a file-based approach. It's really old. It's kind of baggage that we've been carrying around, and we're just kind of getting to it now. And that's all I really have for our story time about Keystone and building our identity access management in OpenStack. By all means, if you guys want to help out, we're always looking for help. We're on IRC. There's a mailing list. There's a whole bunch of different resources out there. And the more identity-related folks that we have out there, the better it'll be. Anyway, any questions and hopefully answers?
You mentioned that the token that is created using Keystone for authentication,
Yep.
it contains all the user information, including roles.
Yep.
If the token is compromised, user information, including group information, role information, everything is compromised as well.
Yeah, you're right. It is a bearer token. So sorry, the question is, if the token is compromised, will the attacker see all the information? And yeah, it is. It's a bearer token, and we kind of want to get away from that approach. We would love to be using, and the token itself is actually all proprietary. It's all not standard. We would love to be going toward a more standards-based approach, something we've been embracing in Keystone for the last year or 2 years. It's trying to embrace standards and make things non-proprietary.
Another question. You mentioned that Keystone is protocol federation agnostic, and you were talking about the Apache modules.
Yep.
Will the modules be supported by IBM in the IBM HTTP server, the IBM version of the Apache?
Oh, okay.
IHS.
Oh, IHS. Okay. So the question was, we mentioned that it is protocol agnostic, and would IBM support the different plugins in IBM HTTP server? I don't know. We use our own built-in distribution of OpenStack, so I don't see why we would be using IHS for this case, because our built-in our own distribution of OpenStack should have just regular vanilla Apache. So that's all it should be using. So we probably wouldn't be using IHS.
So is it more of an open source, support it yourself kind of an infrastructure, or does it have backing of IBM? IBM will support this in case it's used in the organization.
I think it depends on the so sorry, the question was related back to support, and the gist of it is depending on the vendor that you're going to. I mean, OpenStack itself is all open source and will certainly help you out. But I mean, if you're buying it from a vendor, then, ask them. Can you repeat it? What was that?
Processing IDs.
Oh, the processing IDs. Those are not represented in the token, no. We do a lot of logging and auditing, and those would probably be sent on a message queue. Yeah. So if you actually have a messaging service set up, you should be able to see them on the messaging queue. For long-running tasks, short-running tasks, and they should have success or failure messages. No, it's not displayed in the token. Anyway. All right, well. So I think that's it. Anyway, thanks.